Hello students, greetings of the day. This is M.K. Sagar, working as an assistant professor in the Department of Mechanical Engineering, Sagar Institute of Research and Technology, under the prestigious group DSAGE Bhopal. So welcomes you all in today's session. In today's session, we will discuss about the non-conventional machining process, one of the important process, that is plasma arc machining. So let us start today's session on plasma arc machining. Plasma arc machining, uh, one of the important method of non-conventional machining process, uh, and in which the machining process takes place with the help of plasma. The material, excess material is removed from the workpiece with the help of plasma, and in this process, the source of energy is thermal. During the classification, we have seen that the all non-conventional machining processes are classified on the basis of energy utilization. So in this process, the energy is thermal energy. With the help of thermal energy, the plasma is formed, and with the help of plasma, the material will be removed from the workpiece. It is it is mostly used for the metals that cannot be cut by uh, an conventional machining process, because the material is very hard and brittle, that is not possible to machine by the conventional machining process. The plasma is completely high temperature ionized gas, and the temperature lies between the 11,000 degrees Celsius to 20,000 degrees Celsius. So now before we start the working of the plasma or the machining, now let us understand what is plasma. So plasma is a form of gases. When the gases like nitrogen, oxygen, when these gases are heated up above the 5,000 degrees Celsius, 5,500 degrees Celsius, then the atoms of these gases start to break into positive ions, negative ions, and neutral ions. And further, the temperature is increased, and these gases are heated up above the 11,000 degrees Celsius. Then the gases are completely ionized. Means these gases have only positive ions, negative ions, and no neutral ions. So that time the gases are known as ionized gas, and the form of gases is known as plasma. That form of gases is known as plasma. Uh, and this plasma will be used for removal of material from the properties. These are the elements of the plasma systems are power supply. In the system, we require a basic power supply. Then uh, we need a gas supply, nitrogen, oxygen. It depends on the type of material. According to the different materials, the gases are selected. But generally, the nitrogen gases are used. Then cooling water system is required, and the plasma transfer. Now, what are the characteristics of the plasma machining? These are the characteristics of the plasma machining. What is the tool? In this process, the tool is plasma jet, right? That has maximum velocity 500 meter per second. So this was seen in the difference between conventional and non-conventional machining process. In the non-conventional machining process, there is no physical tool, right? Cutting tool, and there is no direct contact between the cutting tool and the workpiece. Always there is a gap, little gap between the cutting tool and the workpiece, and that gap is filled by some medium. So in this, the no physical tool, the tool is plasma jet, right? Then what is the workpiece material? Workpiece material are all conducting materials, all conducting materials. The medium is plasma. Process parameters are voltage, that is 32 to 50 volt, current, that is up to 600 ampere, electrode jet, nozzle dimensions, and melting temperature. Material removal. Material removal, that is melting. Maximum material removal rate is 150 centimeter cube per minute, and maximum temperature is 16,000 degree Celsius. So material removal takes place through melting and vaporization. Maximum material removal rate is 150 centimeter cube per minute. Now, what are the applications of the plasma machining? So these are the important applications where the plasma machining process is used. The process is used for cutting of stainless steel and non-ferrous metals such as aluminum alloys, turning and milling of hardened machine materials, and mostly used for cryogenic high temperature corrosion resistant alloys. Also used in case of titanium plate up to 8 mm thickness. Also used in nuclear submarine pipe systems for welding steel rocket motor case. And the plasma machining is prominent for the applications related to the stainless tube and the tube mills. So these are the applications of the plasma machining process where the plasma arc machining process is used. Now this working of the plasma arc machining process. So in the working of plasma arc machining, in the setup of plasma arc machining, there is a tungsten made of electrode, and it is placed in the chamber. One of the end of the tungsten electrode that is connected to the negative terminal of the DC power supply, and it will act as a cathode. And when the positive terminal of the DC power supply is connected to the workpiece and the nozzle, and this will act as a anode. And in the plasma arc machining, different gases are used according to the different materials. And for example, for aluminum, the nitrogen is used, right? And the for but for most cases, the nitrogen and hydrogen gases are used. And this process employs a high velocity jet of the high temperature gas to melt and remove the material from the workpiece. In the working of plasma arc machining, when the when the power is supplied to the system, an electric arc develops between the tungsten, that is cathode, and the anode, that is a nozzle. As the gas comes in contact with the arc, there is a very high collision between the atoms of the gas and electrons of the electric arc, and as a result, the gases are completely ionized and plasma is formed. And finally, this plasma is forwarded uh, towards the workpiece with a very high velocity through the nozzle, and machining process takes place. During the complete process, high temperature conditions are required as hot gases come out of the nozzle, so there are chances of overheating. So to prevent the overheating, a water jacket is used here in the system. This is the diagram of the plasma arc machining. Working of the plasma arc machining we have discussed. But once again, briefly, we discuss the working of plasma arc machining with the help of this diagram. So this is the electrode made of tungsten placed uh, in the chamber of the plasma arc machine, and the one end of this electrode, which is connected to the negative uh, terminal of the DC power supply. Now it will act as a cathode. Now the positive terminal of the DC power supply is connected to the nozzle and the workpiece, and this will act as a anode. And this is the entrance of the gases like hydrogen, nitrogen, and oxygen gases will enter from here. And when the power supply is given, then the arc will produce between the electrode and the anode. Electrode, that is cathode, and nozzle, that will act as a anode. So between cathode and anode, the arc will produce when the power supply is given. Now, at the same time, the gases will enter through this entrance, and the gases will come into the contact of the arc. And when the gases will come into contact with the arc, there will be a very high collision between the atoms of the gases and the electrons of the arc, and the gases are completely ionized, right? And the plasma is formed. Now, this plasma will be forwarded to the workpiece through this nozzle with the speed of 500 meters per second. That is very high speed. And this plasma will perform, this plasma will come out from this nozzle, the plasma jet, and this will impinge on the workpiece, due to which the material removal will take place. So this is the working of the plasma. Now, plasma arc machining has some advantages, like excessively high temperature are generated for the use. It can be used to cut any metal. This is a very faster process. In this process, the hard as well as brittle materials that can be easily machined. It can be applied to almost all types of metals. It has high cutting rate, and it gives better dimension accuracy in case of machining small cavities. It takes a big part in the automatic repair of jet jets. So these are some important advantages of the plasma arc machining. Now, apart from advantages, we know we all know that each process, if the process has some advantages, then definitely it will have some limitations or disadvantages. So this process has also some disadvantages in the form of initial cost of equipment is very high, quite high. The work surface may undergo some metallurgical changes. Definitely because the temperature is very high, the plasma uh, has the very high temperature in above the 11,000 degrees Celsius. So, and this process involves various equipment, when the cost of this equipment is very high. The entire machining process consumes a high amount of inert gases. Most harmful part of plasma machining, that is metallurgical changes because of plasma, and takes place on the surface. The operator or person handling the whole process must take proper precautions, and this process can affect human eyes. So proper goggles or helmet must be uh, worn by an operator. So these are some disadvantages of the plasma machining. So let us conclude this session. Now, in today's session, we have discussed about the one of the important non-conventional process, that is plasma machining, in which we have understood the definition of the plasma machining, what is plasma machining, and before starting the working of the plasma machining, uh, we have understood about the plasma, what is plasma and how the plasma is formed. After that, we have discussed the working of the plasma machine with the help of diagram. Right? Then we have discussed the applications, advantages, and disadvantages of the plasma machining process. So, thank you very much, and